Annyeong everyone, how are you feeling today? Well, in this video, you will learn about the topic exponential function. Are you familiar with these words? If not, don't worry. We will give you a simple yet understandable informative discussion for this video. Prepare your pens and notebooks for listing down important information while watching and listening attentively. Are you ready? Without further ado, let's start. What is exponential function? Overview of the exponential function. It is one of the most important functions in mathematics. To form an exponential function, we let the independent variable be the exponent. An exponential function is defined by an equation f of x equals b raised to the power of x, where b is any positive real number except for 1. Meanwhile, x is an independent variable and the exponent in the equation. Properties of f of x equals b raised to the power of x are the following. Number 1. The graph of f of x will always contain the point 0 and 1, or put another way, f of 0 equals 1 regardless the value of b. For every possible b, we have b raised to the power of x is greater than 0. Note that this implies that b raised to the power of x is not equal to 0. Number 3. If 0 is less than b and b is less than 1, then the graph of b raised to the power of x will decrease as we move from left to right. If b is greater than 1, then the graph of bx will increase as we move from right to left. Number 5. If b raised to the power of x is equals to b raised to the power of y, then x is equals to y. Here are 5 examples to determine if a function is exponential. Number 1. Y is equals to 10 raised to the power of x plus 8. Answer: exponential function. Number 2. Y is equals to negative 4 times 8 raised to the power of negative 2x. Answer: exponential function. Number 3. Y is equals to 1 raised to the power of 6x. Answer: not, because the base is 1. Number 4. F of x equals ab raised to the power of 2x. Answer: not, because the base is not a real number. Number 5. F of x equals negative 3 over 2 raised to the power of z. Answer: not, because the base is in negative integer. After we determine what are exponential functions, now we will proceed on how to find the zero or zeros of exponential function. Zero of exponential function. It is the value of the independent variable x that will make the function equals to 0. In a graph, it is the x-coordinate of the point intersecting the x-axis. Steps in finding the zero or zeros of an exponential function. Step 1. Equate the function equal to 0. Step 2. Transpose the constant number to the other side of the function. Step 3. If a function has the same base, then equate the exponent and vice versa. Step 4. Solve for x. Step 5. To check, just substitute x to the function.
Now let us all get our dirty blackboard and do some examples. Here are 5 examples in finding the zero or zeros of an exponential function. We have the given y equals negative 256 plus 4 to the power of negative 2x plus 5. We equate the expression of the exponential function to 0. We transpose or transfer the constant to the right side, so negative 256 will become positive 256. Since the base is not the same, rename 256 to have similar base. Since we have the same base, which is 4, we can equate the exponent. Cancel 4 from both sides, then bring down the exponents. Combine like terms first. So 5 will be transferred to the other side, and now we solve for x. Therefore, the zero of y equals negative 256 plus 4 to the power of negative 2x plus 5 is 1/2. Now let us move on to the second example with the given 5x equals 16 to the power of x minus 2. First, we equate the expression of the exponential function to 0. Transpose the constant to the right side. Since the base is not the same, rename 16 so that it'll be the same. Since the base is the same, equate the exponent, and then we solve for the x. Therefore, the zero of the function f(x) equals 16 to the power of x minus 2 is 1/4. Let us move on to the third example with the given y equals 7 to the power of x. Since there is no number that will make the function equal to 0, then the answer is no 0. Now let us move on to the next example with the given 5x equals 2 to the power of 2x minus 1 over 64. First, equate the expression of the exponential function to 0, and then transpose the constant to the right side. Negative 1 over 64 will become positive 164. Since the base is not the same, rename 1 over 64 so that it'll be the same. As for the fraction, the exponent will become negative to get rid of the fraction. Since the base are the same, cancel it, then bring down the exponents. Equate the exponent after. Solve for x. Therefore, the 0 of the function fx equals 2 to the power of 2x minus 1 over 64 is negative 3. Now let us move on to the last example with the given y equals 4 over 2 with the power of x plus 1 minus 16 over 4. First, equate the expression of the exponential function to 0. Next, we transpose the constant to the right side. So, negative 16 over 4 will become positive 16 over 4. Since the base is not the same, rename 16 over 4 so that it will be the same. Since the base is the same, equate the exponent. And once we equate the exponent, solve for x, and therefore the 0 of the y equals 4 over 2 to the power of x plus 1 minus 16 over 4 is 3.
Properties of the graph between 0 and 1. Example, f of x equals 0.5 raised to the power of x. For b between 0 and 1, as x increases, f of x heads to 0. As x decreases, f of x heads to infinity. It is a strictly decreasing function, and so is injective. It has a horizontal asymptote along the x-axis. Y is equals to 0. The value of y is inversely proportional to x, opening to the right side. b above 1. Example, f of x equals 2 raised to the power of x. For b above 1, as x increases, f of x heads to infinity. As x decreases, f of x heads to 0. It is a strictly increasing function, and so is injective. It has a horizontal asymptote along the x-axis. Y is equals to 0. The value of y is directly proportional to x, opening to the left side. Moreover, the graph does not touch or cross the x-axis, asymptotic of the Cartesian plane. The domain x coordinates is the set of real numbers, while the range of y coordinates is the set of positive real numbers. The graph passes through 0 and 1. The graph is concave. Steps in graphing. Exponential function. Step 1. Assign at least 6 values for x and solve for the values of y. Step 2. Summarize the computed values in a table. Step 3. Plot the points based on the table of values in the Cartesian plane and connect them.
Let us get our dirty blackboard and do examples. Here are 5 examples on how to graph exponential function. Take note, the domain of the function is a set of real numbers, while the range is a set of positive numbers. Our given, gx equals 5 to the power of negative x. Step 1. Assign at least 6 values for x and solve for the values of y. You can use any number as long as it follows the same order, like 1, 2, 3, or 2, 4, 6, and so on. Step 2. Create the table of values and compute for each x coordinate. In order to create the table of values, you have to substitute it with the given x. Step 3. Plot the points based in the tables of values in the Cartesian plane and connect them. In this graph, the relationship between the x and y in this graph is inversely proportional. The graph is opening to the right since a is greater than 0 but less than 1 due to the negative exponent. In our next given, y equals 2 to the power of x plus 4. Step 1. Assign at least 6 values for x and solve for the values of y. I am still using one gap between the x variables. Step 2. Create the table of values and compute for each x coordinate. Step 3. plot the points based in the tables of values in the Cartesian plane and connect them. In this graph, it is opening to the left since the base is greater than 0, which is 2. As x increases, the output value grows without bound, while as x decreases, the output values grows smaller, approaching 0. Thus, the relationship of x and y is directly proportional. In the next example, with the given fx equals 3 times 0.2 to the power of x. Step 1. Assign at least 6 values for x, which you could assume as -3, -2, -1, 0, 1, 2, and 3. And then solve for the values of y. In order to get this, you should substitute the values of x to the given x. Step 3. Plot the points based in the tables of values in the Cartesian plane and connect them. The graph is opening to the right since a is greater than 0 but less than 1. As x increases, y decreases, while as x decreases, y increases. Hence, the relationship of x and y is inversely proportional. As you can see, this is easy and simply done. Now let us enhance more of our capabilities with a given y equals 2 to the power of x plus 3. And now, step 1. Assign at least 6 values for x and solve for the values of y. And again, you can use the values of x, -3, -2, -1, 0, 1, 2, and 3. And solve for the values of y. And you know why we will use this -3, -2, -1, 0, 1, 2, 3? Because it's easier since it is much more less than other numbers. Step 2. Create a table of values and compute for each x coordinate. Step 3. Plot the points based in the tables again of values in the Cartesian plane and connect them using the numbers you have computed in the table, with 0 as your x coordinate, and then 8 as your y coordinate, and then so on and so forth. In this graph, it is facing to the left since a is greater than 0, thus the relationship of x and y is directly proportional. Now we are finally in the last example with the given fx equals 27 times 1 over 3 to the power of x. Step 1. Assign again at least 6 values for x and solve for the values of y. And as usual, do the much more easier and convenient way, which is to use lesser number in order to plot and make your table. And step 2, create the table of values and compute for each x coordinate. So 0 will have 27, and then -1 will have 81, and so on and so forth. Step 3, plot the points based in the tables of values in the Cartesian plane and connect them, which as usual, do the 1, 9, 2, 3, 3, 1, and plot them points. On this graph, the relationship between x and y is inversely proportional. It is facing to the left since the base, which is 1/3, is greater than 0 but less than 1. Finally, we reached the end of our discussion. I hope you enjoyed and learned something from graphing exponential functions. Shout out to our teacher and of course our fellow groupmates who did their parts well. I hope you liked the video and thank you for watching.